Well, we're back with the second of our series of videos of going from a unit circle representation to a Cartesian coordinate system representation of trigonometric functions. In our last video, we talked about how we could see sine on the unit circle as a y value of a point here, where the input was the angle here. When we translated that over, the angle here, the pink, was the same as the pink distance here, which is the x value, and the red distance was the same here as this red distance, which is the same as the y, and that gave us a graph of sine, which turned out to be a wave. In a similar way, we're going to look at cosine. Now, once again, in fact, in all of these trig functions, we're going to have the same relationship between theta over here, which is our angle measure in radians, which is the same as this arc length, or the distance that this point at the point 0, 1 traces as it goes through here. That distance there is the same as this distance here. So once again, notice as we spin this around, this increases. So when it gets to here, for example, the angle is pi over 2, which is the same as this arc length. And if we were to straighten out this length here straight, it would go to pi over 2 on the number line here. And if we go out here, it goes a little beyond 3 to the point pi over here. And if we go a little bit further, to say to here, it goes to 3 pi over 2. And if we go all the way around to here, we're almost all the way to 2 pi. Now, I didn't show you this last time, but I can actually put some grid lines on this. If I want, I can put vertical grid lines like this, and then horizontal grid lines like this. So the vertical lines on the grid over here are at spacings of, the vertical lines are every pi over 2, so that lines up with the horizontal axis. And on the vertical axis, we see spacings for the grid lines that I drew in, at least, of 0.1. And there are, for reference, are lines y equals 1 and y equals negative 1. Okay, so that might help us a little bit. And over here I've put a polar grid spacing. Sometimes this is called a polar grid, where we slice this out maybe in some kind of equal spacing here. So here's a unit circle grid spaced in 0.1 either direction. Okay, and then I have also the polar grid. So let me take away that spacing, and we can see some spacing here. So let's take away this spacing. Okay, so now notice as we travel up around here, we're at 0 here. This is at pi over 12 here, which is the distance between one of these guys and the next on the vertical line here. 2 pi over 12, which would be here, reduces to pi over 6. 3 pi over 12 reduces to pi over 4. 4 pi over 12 reduces to pi over 3. 5 pi over 12, and by the way, notice that pi over 3 is just a little bit bigger than 1. The green dot's at 1. The vertical line is just to the right of that here. And then here we go, 5 pi over 12. 6 pi over 12 is pi over 2. 7 pi over 12. 8 pi over 12, which is 2 pi over 3. 9 pi over 12, which is 3 pi over 4. 10 pi over 12, which is 5 pi over 6. 11 pi over 12, and then pi, 12 pi over 12, or pi, and so forth. Notice that this includes a lot of our special angles. For example, pi over 3, pi over 4, pi over 6, pi over 4, pi over 3, pi over 2. This has a reference angle of 60 degrees here, reference angle of 45 degrees here, 30 degrees here, 15 here for the reference angles. So these are in 15-degree increments, or pi over 12 increments. But again, the main thing I want you to notice is that this arc length here is the same as the x here. So what's an angle in the picture on the left is actually not an angle on the right. It's an x value, or horizontal distance. Now, in the cosine of the angle is the x value. So that's this blue distance right here, okay, with the appropriate sign, positive, negative sign. So what I've done is I rotated it up around this circle right here to get the blue distance right here. and then I've just translated that over around this line here and given my height here. So this blue distance here, which is a y value on the Cartesian graph, is an x value on the unit circle graph. So let's get the connection again. The angle measurement over here on the unit circle graph is the x value over here. So the two pink links are the same. This one's curved on the left and straight on the right. Then the two blue links here and here are the same, which is the cosine. So let's check it out. Let's just look at the unit circle picture right now. As we start here, the unit circle, the x value starts at 1. Okay? And when theta is 0. And then the x value is getting smaller, still positive but smaller, working its way down from 1 down to 0, and it hits 0 at pi over 2. Then it works its way up, continues down, sorry, it's negative over here, but getting longer in length, so it works its way down from 0 down to an x value, the smallest it gets is negative 1. Then it starts back up, so it's still coming back, still negative, close to negative 1, but getting bigger, getting closer and closer to finally 0 when we're straight down here at 3 pi over 2. And then it works its way back up to 1. And then, if we keep going around, it will trace the same cycle. So let's watch the point this time over here on the right graph, the Cartesian coordinate graph. So when x is 0, this starts at 0, starts at 0 for x, but 1 for y. There it is. And it starts coming down. And it works its way down here. And it comes down, 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 and hits 0 at pi over 2. Then it keeps going down, and it goes all the way down to hit the lowest it gets, which is negative 1, right there at pi. And now it goes back up, still negative, and it goes back up to 3 pi over 2, and then back up to 2 pi, and then it's going to repeat the same thing. So that's actually tracing out this graph right here. So once again, you can watch the blue dot trace down the graph. It comes down. So notice, like the sine graph, we get a wave here. Notice it's defined for any value. If I were to rotate in a negative direction, this unshaded distance would be the distance across here, and that y value would, that x value there would be the same as the x value here. And so we get those values tracing off to the left and the right. So once again, what do we get? We get, on the unit circle picture, the input is the angle. It's actually an angle, which is an arc length on the unit circle, or amount of distance of rotation of that point 1, 0 as it rotates around the circle. That's the input, which is the angle in radians. But over here, it's also still the input, but it is not the arc length now. It's now actually a x value. So it's an input, but it's an x value. So left picture, the angle is the input, which is this pink distance, and it's exactly the same distance, but it's the x value over here on the picture on the right. And then what else do we have? Well, we have the y values here are going to be cosine of x, whatever x is. Well, what's the cosine of that value? Take that same amount of x, rotate it around here on the x on the unit circle, find the x of this coordinate. So the x of coordinate p here that we see in yellow on the unit circle is the y of this coordinate right here on the Cartesian coordinate system. So let's go to, let me go over here. And let's see. First of all, let's see. Show a coordinate grid. Let's put some axes on that grid. And let's graph cosine. So there's cosine. This actually goes on forever, both directions here. It just keeps going and keep going and keep going and keep going. I can drag this and make it finish graphing out. So it keeps going forever and ever and ever as it keeps going out this way. It just keeps retracing that same basic pattern that it gets from 0 to 2 pi. It gets that on x, it gets that pattern once, and then it repeats that all over and over and over again. So that one cycle, we call it, is called one period. So we get that. Notice that sine was very similar. It's also a wave, and it does keep going and going and going forever as well. But they're a little bit off of each other a little bit. Okay, and so we can see both sine and cosine graph now. Sine is the blue one, and cosine is the red one. Okay, we'll come back in our next video and look at tangent.